Here's another one. We're going to integrate the function x squared times sine of x cubed plus 5. All right, so when we look at these, when we're presented with an integral to do, we want to first think, is this a kind of an elementary form antiderivative, one we can just do? And no, it's not. There's more complicated terms in here, so it's not something we can just do. And so at that point, we try substitution rule. It's the only other technique we really have at this point. All right, so we have this function, and we want to just identify the more complicated piece of our function. So we have x squared, but then we have the sine of x cubed plus 5. I would say that's the more complicated piece. There's more going on there. All right, so when we look at that, when we look at this piece of our function, you can see it's a composite function. There's a composition going on here. We have a outer trig function, and then we have this inner function of x cubed plus 5. And so what we see here is we see sine, and then parentheses, and then something complicated or relatively complicated inside those parentheses. It's not just an x. And so it's those terms that are inside the parentheses, that's how we pick u in this case. So step 1, we're going to let u equal the x cubed plus 5. All right. Now that's not too bad. Now when we look at this x squared, I would consider this like a leftover term. And so it's not absolutely necessary, but I do think it's helpful to take all the leftover terms that you have and move them next to the dx. Still in between the integral sign and the dx, but we're just going to move things around a little bit. So I'm going to rewrite this as sine of x cubed plus 5 first, and then times x squared dx at the end there. All right. Because what's going to happen with this leftover term is in some way that it's going to combine with that differential in some way once we start doing our substitution. All right, so we have this u equal to x cubed plus 5. Let's get the differential. So we're going to calculate du. So what's the derivative of x cubed plus 5? Well, 3x squared, and derivative of 5 is 0. So we get the derivative, and then we multiply by dx. All right. So we want to compare. We know by design this complicated term that's gonna involve our u. So we know in here this is going to become sine of u. Kind of by design. That's how we picked u to be this inner function. So let's look at these leftover pieces. This is sort of leftover. And we want to compare them to what we just calculated for du. And if we look, we have a dx and we have an x squared. If we go over here, there's a dx and an x squared, but we have this extra 3. And that's okay. This 3 is extra, but we can deal with that. So we have this extra constant. And the way we generally deal with an extra constant is, or extra terms in general, is we solve for the leftover terms. So we have this x squared times dx. We're going to solve for this. So we're going to move this constant to the other side by division. So we're going to solve for x squared dx in this case, the leftover piece. So when we do that, we're going to have x squared dx, and we're going to divide both sides by 3. So this will be equal to 1/3 times du. And so this 1/3 du, that's what's going to go in right over here. All right. So it took a little bit of work. It wasn't a perfect match. So our integral had an x squared dx. When we calculated our differential, it was 3x squared dx. So we had this extra constant. So what we did is we solved for those leftover terms that showed up in both the integral and our differential, and then figured out what x squared dx was and plugged it in. So that gives us our integral. once we fill everything in, this sine of x cubed plus 5, that's going to be sine of u. And then the x squared times dx is going to be 1/3 times du. All right. Now this is a much easier integral to do. It's one of our basic forms now. So we can just look this one up. We can just know this one. So what is the antiderivative? Well, 1/3 is a constant multiple, so I'll write that first. And then what's the antiderivative of sine? Well, the antiderivative of sine is negative cosine. And then we have our plus c. And that's step 3, get the antiderivative. And then finally, we need to convert back to x. So we're going to have to fill in x cubed plus 5 right where we see this u. So when we do that, I'll consolidate the negative and the 1/3 and write that as negative 1/3. And then we'll have cosine, and then it'll be x cubed plus 5. And then, of course, our usual plus c. And that's step 4. Go back to the original variable. All right, so we're kind of building these up. And in this example, it's another one where the differential doesn't quite match. And we have to do a little bit of work to kind of get it to match. There's other ways to think about this, but this is, tends to be the more straightforward of the approaches. So you just look, you compare what your integral, what the leftover term is with what you calculated, and you try to match those up. So you solve for the terms that show up in both. All right, and just keep practicing these.